In our previous video, we covered some different terminology to first introduce us to understand some statistics. In this video, we're going to talk about how we actually choose people or experimental units to be in our sample. So we're going to start this idea by looking at an opening example, just looking at a kid's game. So there's this game called Cootie. I play it with my daughter Quinn. If you've never played this game before, the idea is to build your bug fastest, and whoever completes their bug first wins. And so how you decide what part of your bug you get, you roll a die. So one of the things that we like to have happen when we roll a die is we want the die rolls to be random. So why would it be a good idea for our die rolls to be random? Well, when it comes to playing games, one of the things that we like for games to be is for them to be fair. So my daughter being much younger than me shouldn't be any disadvantage to her, right? The idea of the die rolls being random allows the game to be fair. Right, we all have the same chance of winning. So let's just think about these die rolls for a little bit. If I were to roll the die 60 times, would you have any idea what you should expect to see? Well, one thing we usually assume, since we're saying the game is fair, is that we have a fair die. Well, what would it mean to be a fair die? It would mean that each side, numbers 1, 2, 3, 4, 5, and 6, would all happen to land up the same number of times, right? So if I look at having my 6 different options here, I would expect to see the same of each of these numbers. So I'd expect to see 10 ones, 10 twos, 10 threes, 10 four, 10 fives, and 10 sixes. All right, so I would expect the same number to happen. Now, a question we want to ask ourselves after this. Right, this is what I expect to see. If I do actually roll the die 60 times, will this be what actually happens? I mean, even if the die really is fair, am I going to get exactly 10 of each of the numbers happening every single time? So even if it's fair, I'm not necessarily going to expect this to happen. Right, I do not know if that's going to happen or not. I could get something different each time. What I mean by that, if I were to roll it 60 times, and record what happens, but then I rolled it a separate 60 times, I'm not going to get the same thing even then. So something I might worry about then here, how different would still be okay to still believe the die is fair? So if I expect 10 of each number, how different when I actually roll it 60 times could these numbers be? And I'd still think, yeah, it's a fair die. I'm pretty sure we all would agree that if I rolled it 60 times and every single time I got a 1, we're probably not going to think that that's a very fair die. So how different is okay? Well, you're not going to probably like the answer here at first. So first of all, it's going to depend a little bit, right? So for example, if I got 0 ones, 22s, and then 10 of each of the rest of the numbers, that's a little bit different than if they're each only different by 1 or 2. Right, so kind of how the breakdown looks is going to affect things. The other thing that's also going to affect things, as we see throughout our course, is we're going to refer to as our sample size. And let's go ahead and introduce this symbol because we're going to see it a lot. Our sample size is just going to be the little n. What that would represent for us here is our number of rolls. So this may seem like a silly introduction that we're talking about just rolling a die in this game of cootie to understand randomness. But it's an easy way to understand, the idea of random in our class is actually a good thing, right? I haven't written anything negative up here about this word random. Randomness actually is a very useful tool for us here in statistics, because what it allows us to do is we know what to expect. Right? I have exactly an expectation of what should happen when I roll the die 60 times. Here's what I should get if my die is fair. Then I actually can roll my die, see what I get, see how different that is. So then I can compare my data or my sample to this expectation to make some type of decision. So after I roll the die 60 times, I would probably come up with some type of conclusion on, do I think the die is fair or not? And I would have the data to back it up. So the takeaway here, again, remember random when it comes to statistics is a good thing. It's a useful tool that allows us to know what to expect.